Alright, it's recording. Let's get started. Okay, so Simpson's rule, it's a way of measuring. What it actually is Thomas Simpson was a British mathematician, very clever guy. And what he did was, there's lots of different ways that you estimate area. Okay, it's about how do we estimate the area of irregular figures. And so back in ancient Greek times, and since then, there were people who cut irregular shapes into thin strips of rectangles. And then they said, oh, well, let's estimate and work out the area of each rectangle, and we can estimate the figure, like the size of the circle. What Thomas Simpson did, he said, well, let's use parabolas to fit along the edge of line and estimate the area, because you can find out the area under a parabola quite easily with the right technique. So he's a very clever guy. He came up with this rule. So the rule works best when one edge is straight. So if you look at this figure here, this edge is straight along here, and one side is curved. There's no particular shape to it, there's no pattern, it just is what it is. So you can use it with two curved edges, it just doesn't work this way. It's not as accurate an estimate as what it would be with a straight edge, but it'll work with what you've got. And so it's also possible to apply it a number of times. So if you break, the idea is you're breaking up a piece of land or a shape, a figure, into strips. And so the more strips you break it up into and apply Simpson's law to each sort of two segments, the more accurate your reading is going to be. The more accurate the measurement is. But we'll talk about that in a second. I'll give you an example of that. So the rule is the area is equal to h over 3 d subscript f plus 4 times d subscript m plus dl. Then I'm going to go through the notation. So what it is this. A is the area. D, well, first thing is h. H is the distance between each of the lines that we're measuring. From the straight edge, you see here, these D's are measuring from this edge to the other side. And h is the distance between each of those measurements. Right? H is the total distance. H is this distance from the first measurement to the second, from the second to the third. To use Simpson's rule, you need 3 measurements. And this is what df, dm, and dl is. So df is the distance along the first line. This here is df, the distance along the first line. dm is the distance along the middle line, because this distance has to be the same. It has to be equal distance from the last one and the first one. And dl is the final measurement of that line. And h is the distance between each measurement. Alright, any questions first about what we see? Yes, it's to do with quadratic stuff and parabolas. And then, you'd use it in estimating areas under curves. So if you're doing a different course, you could use to work out the area under a curve that's on a number plane, and you use parabolas to estimate that. But for the moment, it's just what it is. Any other questions? Dan, you said something. You don't get it. So you've got 3 measurements, which in a sense, if you think about it, are measuring the width of the land at that point, or of the figure. So this df is measuring the width here, the dm is measuring in the middle, dl is measuring at the end. So at the start, the middle, and end, you need 3 measurements. Yeah, so first, medium, last, first, middle, last, whatever you think. And then this h has to be the same, the distance between the first measurement and the second measurement, the middle measurement, and then the distance between the middle measurement and the last measurement. So the middle really has to be the middle. Okay, first, last, middle, that's it. Yeah, and so if you plug in whatever these numbers are, then you'll be able to estimate the area quite well. The basic idea is, if I just give you, what it's doing is, and you don't need to remember this, but what he did, instead of using straight lines to estimate, it fits the most likely parabola Oh, you know what? No. So, it's okay. Okay, see? What it's doing is it's fitting the most close parabola to this area. Alright, we don't really need to worry. It's fitting a curve of parabola to each section to estimate it. They estimated the area under that parabola. Alright? Any other questions? Yes. Yeah. Yeah, so the measurement we're using in the formula is 1h. It's this h. Yeah, but they have to be the same because it has to be equal distance between the vertical measurements that we use. Yeah, that's right. You don't put 2h in here, you're using just one. But they have to be the same. Alright, so let's have a look at an example. As long as you understand, you don't have to understand how we got it, you just know how to apply it.
Yeah, which makes it
H is simply the distance between two of the measurements.
Okay, and both ways are exactly.
They have to be the same. Apply. I'll show you in a second. Alright. Let's just have a look at this example. Alright, just listen here. What we have here is a piece of irregular shaped piece of a figure. So what we want is, so this is 10 is DF, 11 is DM, and 8 is DL. This 6 is H and H. Right, so we're only going to use 6 once, but it has to be, if this DM wasn't in the middle, you can't apply this in one word. It has to be the same distance. So what it is A is equal to, first thing is H over 3. So it's 6 over 3. DF, which is 10, plus 4 times 11, which is DM, plus DL, which is 8. 2, 10 plus 44 plus 8, so it's 10 plus 44 plus 8 equals 2, 54, 120. Thank you. So we've got 124, whatever the units is, square meters. You know, 6 over 3 is 2. Yeah, it's not always going to be 2, but in this case, any questions? I just said instead of writing a time sign, I'm just showing 4 times 11. Okay? Yeah. Alright, is that clear so far? And what I'm going to do, once this is done, I'm going to put questions on the, thank you, the folder, the shared folder, HSC questions involving Simpson's rule and measurement. Okay, so then you can start looking. This is a favorite. Simpson's rule, I think almost every single time there's some form of something about Simpson. It's one of the sort of key points on this course. You need to understand. Yes. Oh yeah. Yeah. That's good. Yes. Yeah. Okay. So that's the first one. The second one is this. Now, apply Simpson's, so just listening to this one. Apply Simpson's rule twice to find the area of this figure. Alright, so what we could do, yeah, that's what we're going to do. Now, you could use it just once on this and say, well, this is, it's 9, DF is 9, DM is 7, and D, whatever this is, L is 15, and then H is 20 and 20. You could apply it like that. Yeah, and ignore the 13 and 17. And that will be just applying it once. But that's not going to be as accurate as if you applied it. So like I was saying before, the more times you cut it into equal slices and get the measurements and apply the Simpson's rule, the more accurate your measurement is Well, it's a good estimate. It's just saying that the shorter this section, the closer you can find, this formula is finding a parabola that fits to that curve. So that's what it's doing. So let's try this out. A equals, so there's going to be two parts to this. Alright, so what we need to do is identify, I'm going to put two colors. So this is going to be for the blue one, this is DF, DM, DL, and this is H, right? But then in the second application, which we do in red, this becomes DF. So 7 is for both DL and DF for the two applications of this. DM and DL. And that's H and that's H. So what we need to do is apply it twice. So the first thing is 10 over 3, right, DF, which is 9, plus 4 times 13, plus 7. And that's our first area here. So we've done this one. We've done that one. Now the second application, I said, well, plus, H is still 10. So it's going to be 10 over 3 times. Now DF has become the 7. So the 7 goes from DL in this one, and you reuse it to become the first measurement of your second section. So DF is 7 plus 4 times 17 plus 15. Okay? So we found that, got to this point. So we say, well, now we just have to do the work. That's the numbers. So 9, that's going to be 52, 59, 68. Okay, so it's 10 over 3 times 68 plus, that is 68, 75, 90. So it's 10 over 3 times 90 equals 1580 over 3. 1580 divided by 3 is what? Now, Amy, how about instead of doing a game, you tell me what the answer to this is? What is this? A renaissance in this game or something? In the last part they were doing it as well. Huh? 526.67. Okay? Yes. Because it is. Okay? Listening? So, remember, guys, remember this is the formula here. A equals the distance between the measurements, h over 3, the first distance plus 4 times the second distance, which is the middle, plus the last distance. Okay? And you can apply it numerous times. But to apply it, this is an important point, to apply it several times, you always have to have an even number of strips. If you have an odd number of strips, you're going to double up. You're not going to get a good one. You have to have an even number of strips in your figure. Yes? No, because you wouldn't be able to know what to measure. You shouldn't have. Okay, so exercise 4.12. Okay, I'll scroll it. I'll just stop the recording. Hang on.